let's look at one final kind of problem that we want to solve using complex numbers in the polar, or actually in the exponential form. Sometimes you want to take a complex number and you need to raise it to a power. Well, you could multiply this parenthesis by itself 5 times and try to simplify it, but that would be messy and sort of painful. But once again, when we can have a number, a complex number, in the exponential form, then this isn't too difficult. So here's your complex number raised to the n power. And this actually is called DeMoivre's formula. Sounds French. But he came up with, so if you need to raise a complex number to the n power, you simply take your r, you raise it to the n power, and then you have e I times n theta. So in other words, if you have your number written in exponential form, and you want to raise that complex number to a power, you can follow this formula. You simply raise the r number to that power, and then you take the power times your angle. So what we're going to do in a minute, we'll do this problem second. This problem was given to us in rectangular coordinates, so the first step is to convert that into exponential form, and then once it's in the exponential form, then we can apply the power, and it's not too bad. But before we do that, let's take a step back and let's just look at, here is a problem where we're actually given a complex number in polar form. So 2 times cosine pi over 9 plus I times sine. And we actually want to take this complex number and raise it to the third power. So what I'm going to do, and just so you know, they want the answer in exponential form and also rectangular form. What I'm going to do is, let's just rewrite this in exponential form, and then we can use our DeMoivre's formula. So in exponential form, it's going to be 2 e to the I pi over 9. And now we're going to raise that to the third power. And now we can simply use this formula. So it's 2 cubed e to the I, and then you take the angle, multiply it by the power. So pi over 3, or pi over 9. Two cubed is 8. Pi over 9 times 3, 3 pi over 9 is pi over 3. So there's the answer in the exponential form. Now if we want to write it also in rectangular form, now we have to convert this to rectangular form. So here's r and theta. So x is going to be r times cosine pi over 3. Y is going to be 8 times the sine of pi over 3. These are actually special angles. Cosine of pi over 3 is 1/2. Sine of pi over 3 is square root of 3 over 2. So now, in rectangular coordinates, I'll just call this c to the third. It's going to be 4 plus 4 square root of 3 times I. Not too bad. So there's the rectangular and the exponential. Now let's go back. I'm going to grab this problem I talked about initially. Let's go ahead and work this out. And let's give the answer in the exponential form and also in the rectangular form. We call that z to the fifth. What we really need to do first is convert that complex number into the exponential form. And for that, we need r and theta. So r is x squared plus the y squared. It's x square root of 2. Theta is going to be the inverse tangent of y over x, 1 over 1. This is pretty common. This is in the first quadrant. What angle is the tangent of 1? Hopefully, we've done this a lot. So there's r and theta. So this complex number in exponential form would be square root of 2 e to the I times pi over 4. So now, if I want to raise it to the fifth power, I take the r, raise it to the fifth power, and then I'm going to take e to the I, and I'm going to multiply 5 times the angle. So square root of 2 raised to the fifth power is 4 square root of 2. So this is going to be ei to the 5 pi over 4. So that is the exponential form. Pretty simple, huh? Now, but if I want the rectangular form, I need to convert this back to the rectangular. So here's r and theta. So x would be 4 square root of 2 times cosine 5 pi over 4. And y would be 4 square root of 2 times the sine 5 pi over 4. These are both special angles. 4 square root of 2, cosine of 5 pi over 4. 5 pi over 4 is in quadrant 3. Negative square root of 2 over 2. And the sine is actually the same thing. Negative square root of 2 over 2. So let's look at this. Square root of 2 times square root of 2 is 2 divided by 2. Those cancel. It's like it's negative 4. And of course the same thing happens here. So therefore, it's going to be negative 4 minus 4i. So there it is in rectangular form. So DeMoivre came up with a pretty clever and not too difficult way to raise complex numbers to powers.